Hello there, you beautiful people. Now, it's very common when we're working with logic to want to combine multiple conditions into one. And this is where logical operators come in. In this lecture, you're going to learn about the not, or, and logical operators. So by the end of this lecture, you're going to know what these powerful operators are and how and when to use them. This is useful basically everywhere in logic. In fact, without knowing about logical operators, you won't be able to do much real logic at all. So with that, let's get into it. So the first question is, what the heck are logical operators? Well, first of all, logical operators are different to comparison operators. Comparison operators like greater than, less than, equal to, and all those things we covered before, are used to compare pieces of information to make conditions. Logical operators, on the other hand, combine and modify the conditions to make bigger conditions. So comparison operators make conditions, logical operators combine the conditions together. So I'm going to start off by showing you the not logical operator. This is the simplest logical operator and basically gives you the opposite of what the condition would have been otherwise. So for example, not, you can see the way that it's gone yellow, not true gives false, not false gives true. So like for example, if I had not 2 less than 3, okay, 2 less than 3, what's that? That's true, right? So not true, false. What about not 3 greater than 1? Actually, that's going to be false again. Now, what about not 4 equal to 3? That's going to give true, because 4 equal to 3, that's true, not true, false. Now we can use these logical operators in if statements. So for example, if I had x and I set that equal to 10, and I had y and I set that equal to 20, now if I wrote the if statement, if not x less than y, actually no, if not y less than x, then print it worked. And we're going to see it says it worked. And the reason why, well, is y less than x? Is 20 less than 10? No, right? So that would come back as false. What's not false? True. So this whole condition here became true, and therefore this code worked. So you can see the way that the logical operator has managed to modify the condition in a rather simple way. Now we can actually represent this behavior in what's called a truth table. So down here I have a diagram of a NOT gate, or like a NOT operation. This is how they're drawn in circuit diagrams and things like that. So we have an input called A and an output. And instead of writing true and false all the time, but in these truth tables, people write 0 to be false and 1 to be true. And what you can see is that if A, or the input, is false, the output is true. And likewise, if you have the input is true, then not A, or the output, is going to be false. So basically, the NOT gate just gives you the opposite of the input, right? So with that out of the way, let's have a look at the AND operator. Now this is the truth table for the AND operator. You can see that unlike the NOT, which only had 1 input, AND has 2, right? So you've got A and you've got B, and you get 1 output. So the key thing about the AND is that it only gives you true if both of the inputs are true. So if another way of saying that is if A and B are true, then the output will be true. That's why it's called the AND gate. So if you look here, if A is false and B is false, you're going to get false. If either one of them are true, you still get false, but when A and B are true, you get true. So that's the AND gate. Let me show you an example of this in our Python code. So as an example, let's say we have C is equal to 10, and we have D which is equal to 5. Now, if we have an if statement like this, if C is greater than 10 and D is greater than 1, print it worked. Now, why didn't that work? Okay, the reason why it didn't work is because, well, let's break it down. Is C greater than 10? It's not, right? Because C is 10. Okay, so is 10 greater than 10? That's false. So we've got false here. Okay, I'm just going to write this. False. We then have and now what have we got here? We've got D greater than 1. Is 5 greater than 1? Yes, it is, right? So true. Now remember, when you have, this is basically input A, and this is input B. Only if both of those are true will you get true. Okay, so at the minute, we've got false and true, which is false overall. So this overall is false, which means the if statement won't run. Now, if I change it so that if C is greater than or equal to 10, okay, now is 10 greater than or equal to 10? Yes, it is. Okay, so we're going to get true for that. And is 5 greater than 1? Yes, it is. So we're going to get true and true, which is overall going to be equal to true. So this whole thing is going to be equal to true, which means if true, that means the whole code inside is going to run, doesn't it? So if I click that, there we go. So now because both of the conditions are true, our code will work. So now I want to show you something that might blow your mind a little bit. Okay, we can combine not and together, okay, to make a NAND, basically a not and. So let me show you what that is. At the minute, we've got this working, don't we? So what I want to show you is if I change C, let me just take this and just make it just like it was before, right? So this won't work, okay, because we have false and true, okay? That all comes to false, right? You're with me so far. This is exactly what we had at the top here. So what I'm going to do is I'm going to type if not, and then put in brackets like that, okay? Print it worked. So let's have a little breakdown of what this is going to do. Okay, now you remember from the BODMAS and math stuff that we did before, whatever's inside of brackets is going to be executed first. So let's start there. Is C greater than 10? Is 10 greater than 10? That's false, right? So that's going to be false. Is D greater than 1? So is 5 greater than 1? Yes, it is. So that's true. What's false and true? That's false, right? So this whole bracket here is going to be false. So this whole bracket here is going to be false. But what's not false? True, right? So now overall, just by putting the not there, it works. Even though we had the same and condition here as we did here, by taking the not of that, we managed to get the code to work, which is very useful. So the point that I'm trying to get across to you there is the way that you can use brackets to allow operations or logical operations to happen on each other, right? So we used a bracket here to say, take the not of whatever this bracket is, right? If I didn't have the brackets, what would happen is it would take the not of this and this. So that's super confusing, right? But it's the difference between taking the not of the whole thing and taking the not of just this one on the left. By putting the brackets, we say take the not of the whole thing. Without the brackets, we just take the not of what's on the left. So I know it's a bit confusing, but with practice, it makes sense. So in the interest of time, I'm going to cut this video short because we've just got one more logical operator to come on to, which is the OR operator. So I'll see you in the next video to talk all about the OR operator.